Dear students, we have learnt about one method of integration, that is integrating the function when its derivative is known. But this method is not applicable to all the functions. For example, integral tan x dx. Here, if you observe that this tan x, it is not the derivative of any trigonometric function directly. So to integrate this, we need some other methods. So today we learn about integration by substitution method. So how to use that substitution in this case? We'll write tan x as sin x by cos x dx. So this is of the form. For this function, generally we'll use substitution term that is from the denominator, that is now cos x. So cos x equal to t. Once you use the substitution term, convert every term in the function to t form only. So now differentiate this. Derivative of cos x is minus sin x dx equal to dt. So if you back substitute in the function, then you have sin x dx in the function. So sin x dx is equal to minus dt. So integral becomes now sin x dx, that can be written as minus dt. I'll keep that minus sign outside. And cos x, we consider that as t. So this function can be integrated by the method what we know already, that is 1 by t. 1 by t, it is the derivative of log function. So we can write this answer as minus log of mod t plus c. But remember, the final answer should be in the form of x only. So back substitute t value in the form of x, that is minus log of mod of t. What is t now? That is cos x plus c. So if you use the formula n log a equal to log a to the power n, here the term becomes log of mod of cos x to the power minus 1 plus c. That is log of mod of 1 by cos x plus c. That is actually log of mod of secant x plus c. So we learned the formula integral tan x dx equal to log of mod of secant x plus c. Log of mod of secant x plus c. Similarly, we can derive one more formula for integral cot x dx. Use the same process, write cot x as cos x by sin x dx. Use the substitution for the denominator, sin x, let it be t. So if we differentiate this, derivative of sin is cos x, right side will be dt by dx. So that is actually cos x dx equal to dt. So you should observe the fact that after differentiating, whatever the answer means derivative you are getting, that should be there in the given function, means that should be there in the integrand. Okay. So now cos x dx you have, so that is to be replaced by dt, and sin x we consider that as t. So again this is of the form dt by t. 1 by t is the derivative of log function. So integral 1 by t dt, that is log of mod t plus c. So if you back substitute the t value, log of mod of t, t is now sin x plus c. Therefore, integral cot x dx equal to log of mod of sin x plus c. Similarly, we can consider one more formula, integral secant x dx. Integral secant x dx. Here the process is little bit different. While integrating, first write integral secant x into multiply and divide by secant x plus tan x. Secant x plus tan x. So you are multiplying both numerator and denominator by now. Secant x plus tan x into dx as it is. Now use the substitution for the denominator. The denominator is secant x plus tan x, let it be t. Differentiate this. Derivative of secant x is secant x tan x plus derivative of tan x is secant square x equal to dt by dx. You can write this as dx equal to dt. So if you observe the numerator now in the function, see if you multiply secant square x plus secant x tan x, right? So if you multiply secant x with this, so secant square x. So if you multiply by secant x, we'll get secant square x plus secant x tan x dx. Divide by the denominator same term, that is secant x plus tan x. So we can back substitute the values now. That is secant square x plus secant x tan x, that is this term into dx is to be replaced by dt divided by t. So integral dt by t, we know that log of mod t plus c, that is log of mod of t. What is t? Secant x plus tan x plus c. So integral secant x dx is equal to log of mod of secant x plus tan x plus c. Similarly, we can derive one more formula for integral cosecant x dx. Cosecant x dx. Here, consider cosecant x as it is. Now you have to multiply and divide by cosecant x plus cot x. So after multiplying dividing by cosecant x plus cot x, use substitution. Substitution is for cosecant x plus cot x, let it be t. Differentiate this. Derivative of cosecant x is minus cosecant x cot x, and derivative of cot x is minus cosecant square x dx equal to dt. If you observe the numerator, if you multiply these two together, we'll get cosecant square x plus cosecant x cot x. So to get that form, consider minus as the common factor outside. So we'll get cosecant x cot x plus cosecant square x dx. That becomes dt. So in the function, we can write it as minus integral dt divided by t. That is minus log of mod t plus c. That is actually minus log of mod of t. What is t? Cosecant x plus cot x plus c. This is also equal to log of mod of cosecant x minus cot x. Cosecant x minus cot x plus c. So we have learnt about 4 formulas. First one, integral tan x dx equal to log mod secant x plus c. Second one, integral cot x dx equal to log mod sin x plus c. Third one, integral secant x dx, that is log of mod of secant x plus tan x plus c. And finally, integral cosecant x dx equal to log of mod of cosecant x minus cot x plus c. Now we'll consider problems from the exercise 7.2. Consider first question in that. Integral 2x by 1 plus x square dx. So remember, whenever you have a function like this, use the substitution term from the denominator, that is 1 plus x square equal to t. Differentiate this, we'll get 2x dx, that is equal to dt. Observe that this term 2x dx, it is there in the numerator of the integrand, right? So the function can be written as 2x dx, that is replaced by dt, divided by 1 plus x square is t. So this is of the form integral dt by t. We can write it as log of mod t plus c. So if you back substitute the value, log of mod of t, t is now 1 plus x square plus c. Consider second question, integral log x whole square divided by x dx. Just listen to me now. Whenever you have log term in the integrand, use log term for the substitution. Or if you have inverse function in the integrand, use inverse function itself for the substitution. That may be in the numerator or in the denominator. Okay. So now you have log term. So take log x equal to t. Differentiate this. Derivative of log x is 1 by x dx equal to dt. So if we consider dx by x as dt, the function can be converted to the form now integral, see, log x is t, this becomes t square, and this dx by x, that is considered to be dt. Now you can integrate this, integral t square dt. So integral t square dt is equal to t cube by 3 plus c. So back substitute t value, t is log x now. So log x whole to the power 3 divided by 3 plus c. Consider third question. Integral 1 by x plus x log x dx. So if you observe this function, in the denominator you have x plus x log x. From that we can take x as the common factor outside. So the remaining term 1 plus log x. So integral of 1 by x into 1 plus log x dx. So this is the term which includes log. So take that itself for the substitution. Take 1 plus log x equal to t. Differentiate this. Log x derivative is 1 by x dx, that gives you dt. So the integral term is converted to dx by x, that is to be dt now. Here 1 by 1 plus log x, that is t. So again this is of the form dt by t, integral dt by t. So equal to log of mod t plus c, that is equal to log of mod of t. What is t now? 1 plus log x plus c. Log of mod of 1 plus log x plus c. Consider fourth question. Integral sin x into sine of cos x. Sine of cos x dx. Now listen to me. You have two functions, product of two functions now. So, and it is the composite function also. So take the inner function for the substitution. That is cos x equal to t. Differentiate this, derivative of cos x minus sin x dx, that is equal to dt. But you have sin x dx with you, so that is minus dt. Sin x dx, that is equal to minus dt. So integral sine of cos x is considered to be t now. Sin x dx is considered to be minus dt. Minus dt. So now we can integrate this minus. Integral sin t, that is minus cos t. So this becomes plus cos t plus c. So if you back substitute t value, we'll get cos of t. T is now cos x plus c. Cos of cos x plus c. Consider fifth question. Integral of sine of ax plus b, cos of ax plus b dx. So use the substitution for ax plus b, let it be t. Differentiate this, a dx equal to dt. So the function reduced to the form sin t cos t, and dx is dt by a. So here dx is dt divided by a. I'll keep that 1 by a as a constant outside. So 1 by a. Now listen to me. If you have 2 over here, 2 sin t cos t can also be written as sin 2t, right? So multiply by 2, divide by 2. So 1 by 2a, this is 2 sin t cos t can be replaced by sin 2t dt. So 1 by 2a integral sin 2t dt, that is minus cos 2t divided by 2 plus c, that is 1 by 4a cos of 2 times. What is t? T is ax plus b. So cos of 2 times ax plus b plus c. So 1 by 4a cos of 2 times ax plus b plus c. Consider sixth question. Integral root of ax plus b dx. So consider ax plus b equal to t. Differentiate this a dx, that is equal to dt. So dx is equal to dt by a. So the function can be reduced to the form root of ax plus b is considered to be t and dx is dt by a. Keep that 1 by a as the constant outside. So this is equal to 1 by a. See, integral root t dt means t to the power half, right? So half plus 1 means 3 by 2 divided by 3 by 2 plus c. Can also be written as 2 by 3a. Back substitute t value. T is ax plus b whole to the power 3 by 2 plus c. 2 by 3a into ax plus b to the power 3 by 2 plus c. Consider seventh question. Integral x into root of x plus 2 dx. Now consider x plus 2 as t. Dx becomes dt. But remember here x also there. So x is equal to t minus 2 because once you convert x plus 2 to the t form, every term should be in the form of t only. So integral x is now t minus 2. This is root of x plus 2 is considered to be t and dx is dt. Now this is in the product form. There is no product rule under integration. Multiply the terms. So integral t into root t, that is t to the power 1 plus half, that is t to the power 3 by 2 minus 2 root t dt. So this can be integrated easily, that is t to the power 3 by 2 plus 1, that is 5 by 2 divided by 5 by 2 minus 2 times. This is root t means t to the power half. So t to the power half plus 1, that is 3 by 2 divided by 3 by 2 plus c. Simplify all together, we'll get 2 by 5 times t. What is t? X plus 2. So 2 by 5 times x plus 2 to the power 5 by 2 minus 4 by 3 times again t. T is now x plus 2 to the power 3 by 2 plus c. So this is the answer. Consider eighth question. Integral x into root of 1 plus 2x square dx. Again, use 1 plus 2x square equal to t. Differentiate this 4x dx equal to dt. But you have x dx with you. See here, x dx with you. So that is equal to dt by 4. So here integral x dx is to be replaced by dt by 4 and this term, that is under root of 1 plus 2x square, that is considered to be t, right? So if we integrate this, t to the power half plus 1, that is t to the power 3 by 2 divided by 3 by 2 plus c. So the final answer is, if we simplify over here, that is 1 by 6 into t. What is t? 1 plus 2x square whole to the power 3 by 2 plus c. Consider ninth question. Consider ninth question. Integral 4x plus 2 into root of x square plus x plus 1 dx. Now consider x square plus x plus 1, let it be t. Differentiate this 2x plus 1 dx equal to dt. But if you observe the function, you have 4 times. But if you observe the function, in the function we have 4x plus 2. From this, you can keep 2 outside, right? So 2 times. The remaining term is actually 2x plus 1 dx. So that is to be replaced by dt and root of this term x square plus x plus 1, that is considered to be t. So now this is 2 integral root t dt, that is 2 into t to the power 3 by 2 divide by 3 by 2 plus c. That is 4 by 3 times 4 by 3 times t to the power. What is t? X square plus x plus 1 to the power 3 by 2 plus c. 4 by 3 into x square plus x plus 1 whole to the power 3 by 2 plus c. Consider 10th question. Integral dx by x minus root x. If you observe the function in the denominator, we can keep root x as the common factor outside. So numerator remains as it is, integral dx by root x into root x minus 1. Now you can take root x minus 1 equal to t, differentiate this. Derivative of root x is 1 by 2 root x dx, that is equal to dt. So you have dx by root x with you. So that is actually dx by root x equal to, if you shift this 2 to right side, that becomes 2 dt. So integral dx by root x is 2 dt divided by root x minus 1, that is considered to be t now. So this is actually 2 times integral dt by t, that is 2 times log of mod t plus c, that is equal to 2 times log of mod of t. What is t? Root x minus 1 plus c. Thank you for watching this video. We'll continue the other problems in the next video. So keep on watching. Thank you.